alerts of those specific weaknesses or new vulnerabilities emerging to those products. And if there is a vulnerability that you are interested in, you can contact them and request a more detailed analysis, or often they actually automatically provide quite detailed analysis and PCAP files, which is what you mostly are interested in. And then when you get those lists of different weaknesses, you can then just load one of those POCs or proof of concept PCAP files from the database and directly load that into the traffic capture fuzzer and start testing around that weakness. So even before deploying the patches, you will immediately see different variants of the exploits that potentially can cause harm to your test in your test environment. And after deploying the patch, you can also verify that the patch actually did what it promised to do. So fixing all the variants of the problems instead of just a pinpoint one-liner fix that potentially didn't really fix all the problems or all the variants of the problem. And then exactly the same setup can be used to test your IDS system as well. So you can run the test generation technique around that known vulnerability and verify that those IDS rules that you build actually do block all the variants of that same attack as well. So we're running out of time, but actually just in time. So what I wanted to go through in this presentation is really about explaining that vulnerability management is not about known vulnerabilities and testing all of those, because you don't need to care about all the huge amount of different vulnerabilities that basically grow exponentially every year. You only need to know about those, maybe often like only handful of 0 days that actually exist in your production system and which actually are exposed to external attacks. You can't block all vulnerabilities, and you definitely don't want to block every single attack out there. You only want to block those that your system really is exposed to. So this really the only operational solution to that is that you go through this simple process and find out what is really relevant to you, which are those weaknesses that are relevant to you, and block those even before the vendors know about those, even before the hackers go out and start building exploits for those. And it's very simple to do that. You map the attack surface, you map those products that are exposed to attacks, you build those test processes, and you build them both around known vulnerabilities, but also using very intelligent fuzzing processes, because with those techniques you get very good confidence that you actually map and catch most of the weaknesses in the products. And then you start optimizing your defenses so that they actually do what they were intended to do in the first place. So protecting those weaknesses, providing protection or detection mechanisms in order to either fully protect you from those 0 days, or at least giving you alarms and alerts so that you can react to those hacking attempts while waiting for the vendors to actually come out with the real updates. If you're interested in the topic, there's a book on fuzzing which goes through many of these same areas, and it was written by two very well-known fuzzing experts, Jared DeMott and Charlie Miller. And the original purpose of this book was not to write yet another hacking cookbook, but really to write a book for network engineers, software developers, security engineers, academics, in learning why and where fuzzing needs to be done. We should have some time for questions, and also if you have any questions that you want to do offline, you can contact me directly. The best address that always works is info@codenomicon.com, but it's also first name, last name @codenomicon.com. Thank you, everyone.
Thank you, Ari, for the presentation. We already have some questions here. If you have any more questions, please feel free to send them to me through the chat window. And also, like Barry said, if you have more specific questions or more lengthier questions, you can send them to us by email. So the first question, going back to the beginning of this presentation, so fuzzing is an intrusive testing method. How can a network be safely tested with fuzzing?
Yes, definitely. Fuzzing is extremely aggressive testing method. In similar ways, if you look at reactive tools like security scanners and vulnerability scanners like Nessus, many of them have the aggressive mode that you can also use. It means that instead of just doing version number checking, looking at which version of Apache web server you are running, it will actually send those known proof of concept test cases in order to crash the web server or some other not so friendly ways of checking it. Fuzzing definitely is always in hostile mode. So you should at least, if you want to use it in production systems, you should definitely at least warn your customers or your end users that there might be some problems because of the security analysis or verification. And definitely you should first run the tests in a separate test environment, like the virtual test environment that I explained, just to verify that those weaknesses will not crash the production system, but are just used to verify the correct operation of the security updates and such. And definitely if you use very targeted fuzzing, so for example, if there was a bug in one specific header element of a web server, you don't need to run the entire fuzz test process. You can really carefully select a special subset of the fuzz test cases that is focused on verifying that specific weakness, and that way you can also ensure that the corrections are functioning correctly, but while testing that you don't by mistake find new vulnerabilities. You always want to find the new vulnerabilities in the test environment, not in the production environment.
Okay, thank you.